Welcome to Physical Science. Today we're going to be talking about the law of conservation, and I just wanted to kind of get an idea of like what we both know about it. So, what do you think about the word conservation? What do you see in there? Is there kind of a root word?
Conserve.
Conserve. So maybe if you could check out the dictionary. Prevent. What was it we said?
From damage.
From damage or from going away. We'll say from going away. We got mass here, and we talked about that before. You had a pretty good understanding about mass. So if you were to think about mass, we could look it up unless you have kind of an idea of what it could mean. It could mean how we...
and the size of an object.
Okay, so what are those? Weight and size, what are those?
Measurements.
Measurements. How we measure. Yeah, so
Matter.
measurement of matter. I think that's a good definition of it. And so, well, here's another thing. How much stuff is in something? Okay?
Yeah.
How much stuff? Okay. The law of conservation of matter. The law of conservation of matter is what this lesson is on. Okay? Now, here it is. Matter, or stuff, mass, can't, I'll just shorten it, be created, and neither can it, matter, cannot be destroyed. So that's our law of conservation of matter. So we have the two definitions, conserve, mass, and then we also have the law here and what it means. The law of conservation of matter means that matter can't be created, matter can't be destroyed, as long as you don't take anything away, and as long as you have a closed system. So those are, we talked about the examples of physical changes. So the clay, if we flatten it, still has the same, what?
A mass.
Mass. How about if we had an ice cube and we changed the temperature on it?
It melted.
It melted. So if you were to take that water and pour it back into the original container of the ice cube,
it would be this.
It would fill it the same, pretty much, yeah?
Yeah, if it was the same size.
If it was the same size. Mm-hmm.
The cube.
And, well, and like if you have mixed gravel and sand together, the ending mass is the same as the beginning mass. So you have sand, gravel, and then mixing them together.
It's the same.
It would be the same mass.
As both the individual added together.
Okay. So now we're talking about physical changes of things, right? We're now going to be talking about chemical changes. So do you think it would work? The law of conservation of matter with a chemical change in a closed system?
I don't know.
You don't know. Well, that's a good question. So we're going to be discussing that later. We're going to be doing an experiment to test that out. We're going to be using a couple of chemicals, safe chemicals, but we're still going to use safety glasses. And we're going to do an experiment, and we're going to test it out. Okay? So meet me back in here in about 20 minutes, and we'll do that.
Okay.
Okay? Thank you.